Hey guys, this is screencast number 2 for Unit 8, Lesson 3, and I'm on page 457. So it says, what are the oceanic factors of global weather? The warm surface water near the equator flows toward the poles. It transports energy as heat as it moves to higher latitudes. This is again that deficit versus surplus. In the tropics, we have a surplus of solar energy that's being absorbed, and closer to the poles, we have a deficit, meaning we've got a shortage. And so we've got to take that excess heat energy that we get near the equator, and we've got to move it towards the poles. And oceans are one way to do that. So they take water and they circulate it, taking warm water from near the equator, and it moves towards the poles in these large cycles. Some of them are organized enough that we call them an ocean gyre. But basically, we're taking warm water and moving it towards the poles. We're trying to even out the heat imbalance. Okay? Just like winds, the resulting convection currents in the ocean transport energy as heat from place to place. Okay? So we've got convection currents that work both in the ocean and in the atmosphere to transport energy. Energy, this in this regard, is heat energy. All right, so some oceanic factors affecting global weather. Now we have a little smaller bullet point. One of those factors happen to be surface currents. Surface currents, remember, are currents that are literally near the surface of the ocean, up to, about 100 meters down or less. Okay, so an ocean current, in general, is a movement of ocean water that follows a regular pattern. Ocean currents that occur at or near the surface of the ocean are called surface currents. Okay? As surface winds blow across the water, they drag ocean water along with them. So therefore, surface winds determine the direction in which surface currents flow. You guys have already discovered that for the most part, winds proceed from east to west along the equator. Okay? So it shouldn't come as any surprise that most of your surface ocean currents tend to move from east to west along the equator as well. Okay? All right, so surface currents may be warm or cold. Well, obviously, if there's surface currents near the equator, they're probably going to be warm currents because that's where the water is warm. And you're going to have cold ocean currents closer to the poles. But again, we set up a cycle so that the cold water towards the poles eventually is turned back and heads back towards the equator, where it can be warmed up, and then that warm water is sent away from the equator towards the poles, so it cycles. Cold surface currents generally move colder water from high latitudes to lower latitudes, meaning from somewhere far away from the equator to somewhere closer to the equator. Okay? Here's a great question. Which two currents have the greatest effect on weather in North America? And specifically, we'll just talk about the United States here. Okay? If you look at North America, over here we have a warm water current called the Gulf Stream. Okay? It brings a lot of our Atlantic storm systems up along the East Coast in the summertime, but it is a warm water current because it's taking water and trying to move it away from the equator. Over here on the Pacific side of North America, we've got the weather along like California and Oregon and Washington over here on the West Coast. It's being influenced by the California current, which is actually a cold water current. So the California current is taking water from closer to the poles and attempting to bring it back to the equator. So even if you're at the same latitude in North America, your weather over here on the East Coast is likely to be warmer than a similar place over here on the West Coast, because the East Coast is influenced by a warm water current, the Gulf Stream, and the West Coast is influenced by a cold water current known as the California current. So those are really important. Okay, and I think that that's addressed in more detail, on the next couple of pages. Okay? So, some examples of warm and cold water surface currents. The Gulf Stream is a warm water current that flows northward along the east coast, and the California Current is a cold water current that flows southward along the west coast. Those are two surface currents that you need to know by name, and you need to know where they're located. Okay? All right, the Gulf Stream helps to keep Ireland, Great Britain, and northwestern Europe warmer than most places at that same latitude are farther inward. So if you look down here, here's what they're talking about. Here's the Gulf Stream bringing warm water, and it moves across the Atlantic in this big Atlantic gyre, and it helps to bring warmer conditions over to this part of Europe. And what they mean is that this part of Europe sees a little bit higher temperatures than other places at the same latitude, maybe up here in central or northern Canada, something like that. Okay? All right. Solar energy, I'm right here, causes water at the ocean surface to evaporate. Energy that is released when this water vapor condenses is the driving force of a storm. And the most important factor in the formation of tropical storms is water temperature. I think we've probably said this several times as we've covered tropical storms and hurricanes. The biggest factor in whether you're going to get tropical storms and hurricanes to form is whether you have warm ocean water. Okay? Tropical storms form over certain areas of warm water around the world, including the southern part of the Gulf Stream. Okay? We frequently have tropical storms and hurricanes that are forming down in this area. Okay? On the west coast, we really don't worry about those because that is influenced by a cold water current, so that's not going to really happen. Okay, California Current is the cold water current that influences weather along the west coast of the United States. Because of this current, land along the west coast of the United States is cooler than that along the east coast. So if you had a friend living in San Francisco and you had another friend living at the same latitude but over on the east coast, generally speaking, the person on the east coast is going to be experiencing warmer weather than the one living on the west coast in San Francisco, even though they're at the same latitude. And that is simply because over here in California, you're being influenced by a cold water current, and over here on the east coast, you are being influenced by a warm water current. Okay, obviously this is a zoomed in, just a little snippet of California. This isn't the whole west coast. Okay. Frequently, we get fog in California because, for instance, warm air that flows across the cool waters of the California Current cause fog. Okay, fog is very frequent in certain parts of California. Okay. All right. You don't have to think outside the box, but there is a little reminder over here that you have large circulations of ocean currents that form like these loops. Those are your ocean gyres. There's 5 major ones: the North Atlantic Gyre, the South Atlantic Gyre, the North Pacific Gyre, South Pacific Gyre, and then the Indian Ocean Gyre. Okay, they have big influences on global weather. Okay, I'm now on page 460. We're just going to touch a little bit on El Nino and La Nina. Okay, they are very, very big, broad topics within meteorology, and they're very complicated. So it's probably a little more than what we need to get into here as 8th graders. Just understand that El Nino is a period of change characterized by above average ocean temperatures across the Pacific Ocean. So if you look down here at this graphic, you're noticing this large area in the central Pacific Ocean that's very warm. And it's going to cause some overall general weather patterns that are unique to El Nino conditions. La Nina is a periodic change during which below average temperatures occur in the eastern Pacific Ocean. Okay, so here would be La Nina conditions. Okay, the really, really hot stuff is way over here by Australia. And again, remember, the Pacific Ocean covers like half of the globe. So when you have alterations in the temperature of the Pacific Ocean, which makes up almost half of the surface of the Earth, it's going to affect your weather patterns. Okay? So both El Nino and La Nina affect wind patterns and the positions of the jet streams and global weather in general. Okay? All right. During an El Nino, high pressure builds over the western Pacific Ocean, generally. At the same time, low pressure builds over the eastern Pacific. As a result, trade winds normally blow from east to west. They are weaker than normal, okay? I don't really expect you guys to memorize this because these are some broad overarching topics, okay? But just understand that El Nino can have one effect on an area, and La Nina can have basically the opposite effect, okay? So higher than normal conditions in the Central Pacific, cooler than normal conditions in the Central Pacific, and they can drive a lot of big-time changes in weather. I would encourage you, I mean, you can write these down if you want to, but that's a lot of more specific detail, and I'm not going to ask you to tell me specific factors about El Nino and La Nina. But what you really need to do, the thing that you really need to understand is that they are changes in the temperature of the Pacific Ocean in certain places, and that has a big influence on global weather patterns, okay? And I think that's good enough for us for now. And that takes us to the end of the lesson. And so you've got lesson 3 knocked out. Congratulations.